Hi. I'm probably the only Dutchman he knows, so that's, yeah. And I promise I won't set fire to the theater, at least I'll try not to. So my name is Niels, and you may know me from a website called HTML5 Tests, and I am a Mozilla Tech speaker, I'm a Google Developer Expert, and a Microsoft MVP, which 10 years ago would be kind of awkward to say at a conference like this. But I tweeted HTML5 test, and I have to admit one thing beforehand. Unlike my impressive flaming code skills, I actually kind of suck at drawing. And as you will see throughout this talk, and I'm very sorry about that up front. So now, I love the web. I've been a web developer since 1994, and I've written my first HTML 25 years ago. So, yes, I'm old. I love HTML, I love CSS, and I've even grown to love JavaScript. And I love electronics. So when I was a teenager, I had this cardboard electronics kit with all kinds of different components, and it had wires, and you could connect them together with clipping the wires between little springs. And you could create a radio, or you could create a transmitter for Morse code. And yeah, this is my drawing skills. This is pretty awful. This is what I have now. There's still some components to connect together with some wires, but the components have become much more advanced. Instead of transistors and diodes and resistors, we now play with microcontrollers and all kinds of sensors. And everything works together. Now, I know some of you are thinking, why should I care about this? I am a web developer. I don't have anything to do with electronics. And you're probably right. But when you connect devices to the web, like electronic devices that you make yourself, you get the Internet of Things, and you get devices that talk to servers, or even directly to browsers. And there things are starting to get interesting for web developers. So first of all, having a little bit of knowledge about IoT and connected devices is very useful, because these kinds of devices will only become more pervasive. And there's a good chance that you will encounter this in your day job in the future. Well, maybe not programming devices, but building apps and interfaces that talk to devices. So technologies like Web USB and Web Bluetooth are being rolled out to browsers, and it makes sense for us to get to know this. But it is also extremely interesting because there's a lot of engineering directed towards connected devices. This is where technological innovation happens extremely fast. And if you want to know about cutting-edge stuff, this is the place to be. And the most important part, it is also a lot of fun to play with this technology. Even if you will never use this in your day job, it's just an amazing experience to, let's say, build a web app that talks to a microcontroller to drive around a toy car. Now, the main issue I've seen when web developers start playing with microcontrollers and IoT is the barrier of having to learn C. Now, C and JavaScript may look quite similar syntactically, but it is a completely different beast. You not only need to learn C, but also low-level programming concepts like memory management, pointers. And even though I learned this way back in school 25 years ago, I am a dinosaur, I hate this. What if we could use a language that we already know? What if we did not need to worry about those low-level concepts? What if we could use JavaScript on microcontrollers? And not only that, what if we could leverage the browser to connect these microcontrollers and let them extend each other's capabilities? Now, this is all fine and well, but microcontrollers are slow. They are really slow. Now, when I say slow, that really does not convey the idea of how slow they actually are. They are slow. So take, for example, the slowest computer you can buy today, the Raspberry Pi. This is the 0W, and it is slow. So all Raspberry Pis are slow, but this is the slowest they make. And it's still a great little computer. It runs Linux, and Node.js, and runs a full browser like Chrome or Firefox. But this is a computer. This is not a microcontroller. Now, this is a microbit. It's a little board created for school children, and it runs just at 16 megahertz. It has only 16 kilobytes of RAM. Sorry, max. Kibibytes of RAM. It is slow, but it's not even by far the slowest microcontroller you can find. But it is fast enough to run JavaScript. Now, comparing to the Raspberry Pi, and that's about 60 times faster. It has way more memory too. So the microbit is on a completely different level. Now, when I started working with computers 32 years ago, back in 1987, I know, I'm old. We had an Apple Mac Plus. And it was a fantastic computer back at the time. And I learned programming on it, and it was pretty slow, even back then. I still loved it. It booted up from a floppy disk, and after a couple of minutes, you could remove the operating system floppy, and then insert an application floppy, and then start the application. Then, after a couple of minutes, whenever the app needed something from the operating system that wasn't already loaded in memory, you had to swap the floppies again. And all the while you used the app. Now, eject the app floppy, insert the OS floppy, and vice versa again. It was awful and fantastic at the same time. Now, this is 30 years later. This 30-year-old computer is probably more advanced than most microcontrollers. It's probably just as fast as a microbit, definitely more memory. It had a whopping 1 megabyte of RAM. And here we are, 30 years later, and we're going to run JavaScript in something that is less advanced than this thing. So are you crazy? Well, 2 years ago, when I started playing with microcontrollers, I would have said yes. There are, however, very good reasons why running JavaScript on microcontrollers is brilliant. First of all, JavaScript is easy compared to C. 2 years ago, I created a gadget for showing notifications from my home automation system on an 8x8 pixel LED screen. So whenever I get mail, you know, the physical kind of mail, actual letters, in my physical mailbox, it shows me a little icon of a mailbox, so I can go outside and fetch it. So this is an impression of me getting mail, and this is the pixel display. It's actually a ceiling light that I improved. And it shows a little icon of a mailbox, and I wrote it in C, and it took me 877 lines of code. That's excluding all kinds of libraries I had to use, and we are going to create this project in JavaScript today, and it's going to take us less than 30 lines of code. That is what sold me on JavaScript on microcontrollers. Now, microcontrollers are very power efficient. I can run JavaScript on a tiny little Bluetooth-enabled board and power it using a coin cell battery. And it can run for months. So slow is a good thing. Because when we make things faster, they require more power. And microcontrollers are fast enough. Yes, they are slow, but we only have to solve very small problems. So microcontrollers are fast enough for everything I'm going to show you today. And finally, they do not need an operating system, at least not in a traditional sense. So that may sound bad, but it's actually fantastic. Because when I flick a light switch, I do not want my Linux-powered lamp to take 45 seconds to turn the lights on. Yeah, so how can we do this? So let's take a look at at how we can get JavaScript on microcontrollers. So there are lots of different projects in various stages of maturity and supporting different types of microcontrollers. And we're going to focus on Esperino. It's an open source project. You can also buy hardware with Esperino already installed, so it's plug and play. But there are also versions you can actually flash yourself on your own hardware. And it's an interpreter that supports most of JavaScript, even some ES6 features like arrow functions and so. And it has a REPL functionality. That means that if you connect it to a computer, like using a USB cable or using Bluetooth, you can run JavaScript code on it just like you would in the console of a browser. Now, it supports multiple types of microcontrollers, like the ones based on the ESP chipset from Espressif. So this is basically just a Wi-Fi chipset that has a small microcontroller. It was originally intended to add Wi-Fi capabilities to existing microcontrollers, like an Arduino. But in its own right, it's also a very powerful microcontroller. Now, the most famous example is of an ESP-based microcontroller is a Node MCU. Now, there are many cheap microcontrollers, boards that you can buy for a few euros on sites like AliExpress or in your local electronics store. And the other chipset is the Nordic NRF52. So these are a little bit more expensive than the ESP, ranging from 15 to 40 euros. So there are some options, like a puck.js, which is basically a small button with a coin cell battery, or pixel.js, which has a screen. You can program little games on it, like the offline dinosaurs game. It is Arduino pin compatible, so you can use all kinds of shields, like motor controllers, and that is exactly what I used in one of the demos. Now, this is the microbit again. I would not recommend using this for, except maybe the most basic projects. And finally, the Nordic thingy. This is a device created by the same company, Nordic, and it has an amazing amount of sensors, buttons, an LED, rechargeable battery, and you can use all of that from Esperino, and I brought some of them with me. So after this talk, if you'd like to start playing with microcontrollers, I can give a few away, just a limited number. But come up to me, and I might have one left. So now it's time for the demos. This is the fun part of the talk. I hope. For me, it's not so much fun because I'm actually pretty nervous. Because we had some demos so far during this conference, and they all worked. So mine is destined to fail. I do have some warnings to give, because this is cutting-edge stuff. Hardware demos with experimental technology, and most of it is using Bluetooth, which is wireless connection, and Bluetooth uses the same frequency as Wi-Fi, and this room is filled with Wi-Fi devices. So this is the moment where my heart rate goes through the roof. Actually, last year I was in a little car accident, and I was wearing a heart rate monitor. And I was also wearing a heart rate monitor during one of my talks. This is about car accident. This is just before I give a demo. So, yeah. So let's get on with it. The first example, a connected light bulb. So to create this, we need some LEDs. This is a NeoPixel ring. It has 24 individually addressable LEDs. And so you can change the color of each of these LEDs to a certain color. And you need wires, 3 of them, power, ground, and 1 for the data. And you need a microcontroller. This is an ESP32-based Node MCU. So I brought that with me. So Let's see if this works. Yes. This is it. Now, when I connect this to my computer, it does nothing. Don't worry, that's what I expected to happen. This is not a failure. This is, yeah. So let's program this. First, we're going to need a color. RGB, this FF9900, this is orange. And we need a buffer to put those RGB values for the LEDs in. So we need a buffer of 24 RGB values. And now we need to fill that buffer using a little loop. And we're going to set an RGB value to each of these LEDs in the buffer. Now, you notice that is for slightly unusual order for the RGB here, GRB. That is because the NeoPixel, works like that. And now we have our buffer full of RGB values. And now we need to use a library and use that to write that buffer to the D15 pin. And that is the pin on which the data cable is connected. Now, let's actually connect to the device and upload. So, this is it. So, thank you for your time. I can do a little bit more with it. Yeah. So let's replace this with a mathematical function. Let's create a gradient from blue to red. Upload it, and it works. So you can figure out yourself. You can basically use it to do anything. Well, okay, change colors, not anything, change colors. Let's make it a little bit more complicated. I'm going to use an interval at 16 milliseconds, and I'm going to write make some pixels red, make some pixels blue, and I'm going to rotate it around its axis. Let's upload. And we have an alarm. Oops. Now, let's do a little bit more. Let's get rid of this and go back to our original example and make it orange again. It's boring. Make it a little bit easier to use. Instead of doing this in line, make it a function called the update function. That doesn't change anything, it's still orange. It's still orange. But now we have a function, and we can change the value of the color and call update, and it should get a new color. Let's use Bluetooth. So we're going to advertise our device as an Espruino Lite. We're going to offer some services and characteristics, make that writable and readable. And the value of that characteristic is our RGB color in 3 bytes. And if somebody writes to that characteristic, we're going to use the bytes that we get and assign it to our color and call update. Now, I can do it like this, but I also brought something with me. disconnect that one. This is basically the same thing, except I build it in a light bulb. I'll connect that. And it's supposed to be orangey. Not really visible in this light, but let's now, thank you. Let's go to a browser. So I can use the browser to connect to this device using the Web Bluetooth API. And to do that, I need to call navigator.bluetooth.requestDevice and specify the name of the device, like Esperino Light, and offer an optional services array with the service I defined in the device. So if I execute this, a dialog will pop up, and I can connect to the light it found. Okay. Next, we're going to need to open a connection to the GET server on the device. Done. We're going to get our service. Done. And we're going to get our characteristic. Now, this is 4 lines of code. I can now call the write value function on the characteristic and send over 3 bytes. Like FF0080, this is pink, I think. I can do some more examples. I can make it red or green. Just 5 lines of code in a browser, and less than 30 lines of code on the microcontroller. And we have an IoT-connected light bulb. I can quickly show you something else. I can connect to some light bulb using a web app. It's basically calling the same 5 lines of code. But I can also do something else. Like I said, we can extend each other's capabilities. So we can use CSS animations on this thing. It's not really fair because it's running in the browser. And now it's turned black. Yeah. So this is fun. This is fun. But we can do so much more. So let's get this out of the way. And I have here the LED pixel display. I'm going to try. The cables are a bit short. And not drop it. And let's get rid of this. Connect to the device. There it is. And we're going to write some code. So first, again, we need a buffer. This time it's 8 by 8 by RGB. We need a function to draw. So we have a position that's from the top left to the bottom right. And we have an RGB value. Now, we're going to set that RGB value again in the buffer in a certain position. And we're going to write that to the D4 pin in this case. Now, to clear the screen, we're just filling the buffer with zeros. Just make it black. And just like the light bulb, we're going to advertise it using Bluetooth. And we're going to make it writable. And in case the first byte is a 0, we're going to clear the screen. And if the first byte is a 1, we're going to draw. And the second byte is then the position, the third, fourth, and fifth RGB. So this is less than 30 lines of code. So let's upload. And I'm going to save this, flash this on the device itself. And I'm going to disconnect. And I have a different demo here. I'm going to connect to it. This is always a tricky part. Is the device actually showing up? Yes, thank you. So let's pair, and I'm going to draw a self-portrait. Is it actually working? Yes. So. "30 lines of code. I think this is amazing. Now, I do have one more thing. But this terrified me. But the next thing is actually is way worse. This is I brought a car with me. It's a Lego car, not a real car, but still. I'll go back here for a bit. We've had the pixel display, the remote-controlled car. This is just a Lego car, and I added an Arduino motor shield and the Pixel.js, and well, they snapped together, and I built some Lego to connect it to the car, and then it should start driving. Well, after I program it. So let's turn this thing on and get rid of this. Now I should wait for the car to appear and not do this on the pixel display because that won't make sense. Let's get rid of that. So to drive, well, we need a function called drive. I'll explain later. Now, this function, calls or writes certain values to certain data pins, and those pins are determined by the motor board. So the D12 and D13 pin is basically making sure the motor turns clockwise or anti-clockwise. And you'll notice here, the left motor is low-high, and this is high-low. This is reversed. That's because the motor is turned 180 degrees. So the next one, the D3 and D11, that is the power. We're going to use full power. We're not going to bother with slow cars. We need a function to stop. This is very important because so we're just going to set the power to 0 and it will stop. This is getting really scary. Next, functions, forward, reverse, left, and right. So basically, forward is both motors, full power. Reverse is, well, reverse is basically the other way around, and left is one motor forward and the other backwards. It is something with the lights here. I hope I'll reconnect. Not the pixel. The car, yes. I'll upload this. All right. Now this is very tricky because I have to type and at the same time try to prevent this thing from falling off this table. So we're going to turn left, turn right, and stop. So, this worked. So let's make this a remote-controlled car. We're going to add some Bluetooth code again. We're going to advertise it. Characteristic services, you've heard this before. And we're going to look at 1 byte. We're going to send 1 byte to this thing. And depending on what the value of that byte is, we're going to go forward, left, right, reverse, or stop. Now, the values of these bytes are A, W, S, D, which is kind of like arrow keys. Let's upload this. Save it. And now, I'm actually going to put this on the ground. Disconnect. Wait. Now, it will be really embarrassing if I now crash the car and destroy the flag, but I'll try not to. So let's try this. Oh, stop. I can see I have just a minute or two left. Now I'm going to perform a very daring stunt. I'm going to try to not crash this car while steering it from this table straight into the audience. And I have just 1 shot. So if I fail, I'm going to have to buy a new car for my 4-year-old son. Yeah. Okay, let's do this again. The reason it was kind of itchy a few minutes ago was that it actually it contains a LiDAR sensor, a laser range finding sensor. And I can use that to measure distance. So I'm going to measure, and if the distance is over a certain threshold, we have an emergency mode. It's going to go full reverse, and once it's clear again, once it's on safe grounds, it's going to stop. Hopefully. This worked at home about 75% of the time. I must not forget to actually initialize the library and start using an interval to measure, because otherwise it just... right. Upload. I'm going to save it. Done. I'm going to disconnect. Now a very important part that I learned early on. Now I have to power cycle, because otherwise... There we go. now it should work. I hope. Let's connect again. I am not going to try again. I'm already way too lucky. Well, I hope you enjoyed this. I hope you can see the potentials of this technology. And like I said, if you're interested in this, power switch. Okay. If you're interested in this, I have a couple of the Thingy 52s with me. So come up to me after or during the break, and I might have one for you. So, thank you.